How to read a WPS. Gary A. Pace, PE, CWI, March 2019. How to read a WPS. My general goal on this is to show people how to read a WPS. Not that it's rocket surgery, and yes, I did mean to say rocket surgery. Not that it is rocket surgery, but if you've never read one before or don't know what you're looking at, it can kind of be daunting. I had a friend that was a structural engineer, and we worked together years ago, and he approved some WPSs and some welding documents a couple of years before I worked with him again, and I gave him a bad time, and he was like, dude, I'm a structural guy. I don't know. I was handed these by my boss, and he said to approve them and he's like, I just went through them and kind of, it was welding related, so I assumed the people writing it knew what they're doing. So anyways, I kind of always would bust his chops about it. And if you're a civil or a mechanical or some engineer that gets thrown a stack of WPSs and told to review them or figure out what's going on or does this comply to the code, hopefully this will help you out. That's my goal. See if we can hit the target on that lofty goal. The Welding Procedure Specification is a required document for all code welding. Your customer either directly or indirectly specifies to what code your company must qualify. The WPS outlines all of the parameters required to perform your welding operation. In short, the WPS is the recipe for welding operations. It describes the welding process or processes used, the base materials used, the joint design and geometry, gases and flow rates, welding position, and includes all of the process, conditions, and variables. Each code has a recommended format. So we're just going to kind of take a dive into this, see what happens, talk about WPSs, but long and the short of it is a WPS is a recipe. The welder should follow that thing verbatim. If it says shake a bird's feather over it when you're done of a certain species of bird, then by God, you do that. That's how it works. And if you say they can hit it with chicken feathers or goose feathers, all right, that's up to them. Or if you're really stringent and you say it's got to be a certain kind of goose feather from a certain kind of goose that only is found in Lithuania, then by God, the welder needs to follow those directions. Either that or you need to rewrite your WPS. But anyways, we'll get into some of this. You can see here's a suggested format for welding procedure specifications. You don't have to follow this. You have to address all the essential and non-essential variables, but you don't have to follow this format. You can invent your own format if you want. Nothing says you have to follow the suggested format. They give you an idea. Yeah, this is one that works for a lot of people. You want to use it, run with it. If not, invent your own. I worked at a couple of places where they had everything written out and it was in paragraph format and they addressed everything. And it wasn't in a grid or kind of a table layout like this. It was in paragraphs. And there was a couple of little tables in there about materials and whatnot, but it was a completely different format, completely legal. Clients liked it because it addressed everything and everything was written down and there was no way to get around it. One of the problems with welding procedures and PQRs also that people that aren't really initiated into the craft have problems with is that they'll end up thinking they have to fill in every blank on the WPS or PQR. You don't have to fill in every blank. You just need to look in the code and address certain variables, the essential and non-essential variables that need to be addressed depending on what you got going on. WPS, you have to address essential and non-essential, and a PQR, you just need to address the essential. You can address the non-essential variables on a PQR, but anyways, just because there's a blank there doesn't mean you have to put information in there, because it's probably going to get kicked back if the reviewer knows what he's doing. He's going to ask, why did you put this here? What does this mean? This doesn't have anything to do with what you're doing. So some procedures some welding processes have variables that other processes don't. Shielding gas. Shielded metal arc does not have shielding gas. Gas tungsten arc welding does. So you have gas. Not as a shielded metal arc. If you're writing a shielded metal arc welding procedure, don't address shielding gas. So that's the advice or the rant for the welding procedure specification. Here's an example of an AWS D1.1 pre-qualified weld procedure. You can see this is the standard form. You can get it out of the AWS D1.1. You can use another format. You're not stuck with this one. This is just kind of a general run-of-the-mill procedure. And you can see that you can use it either as pre-qualified, qualified by testing, or as a PQR. So you just check the boxes on, what type of document you're going to use. This can be a procedure qualification record. You check the procedure qualification record up top. Or it can be a WPS, and in that case you check whether it's pre-qualified or qualified by testing. But if this is like I said, here is an example of a pre-qualified procedure, we don't need to do testing. We're just going to go through AWS D1.1, the pre-qualified section, which is clause 3. Used to be sections, but then it got confused with ASME, the American Society of Mechanical Engineers. They call their stuff by sections. So the American Welding Society calls theirs clauses, which is like a chapter. But anyways, I digress. With a pre-qualified procedure, you just go through clause 3, and you pick out your weld metal, you pick out your base metal, you pick out your positions, your shielding gas, whatever is appropriate for those pre-qualified weld processes like shielded metal arc welding. So if everything falls within the parameters of clause 3, you have yourself a pre-qualified weld procedure. But this is what the form looks like. On this one, I'm just going to start. Here's one from Fred's Welding, 3500 Chickenfoot Road, Elkhorn, Montana, 59784. I don't know. I just made it up. Elkhorn's a little town outside of my hometown in Montana. But anyways, so we'll start at the top and we'll just work through this. So the big thing is here the company name, Fred's Welding. So you could have a situation where you'd think, oh, well, why do I care about the name? Well, I've worked at companies where there's been mergers and buyouts and whatnot. And if Company A buys Company B, they get all of Company B's welding procedures. So you might run across a situation where the welding procedure is in a different name. So you might want to address that. But as long as they're under the same corporate umbrella, they can use them pretty interchangeably as long as it's all the same organization. And they all, how do you say, I forget the wording in the code, but as long as they all claim it. You can see we've got revision number. That's a biggie. A lot of times you'll be welding, you might go out in the shop and the welders are welding with the wrong revision. That's something to keep track of. And you can see right below that we've got our supporting PQR number. A PQR is the document that is going to support this. So this is ASME boiler and pressure vessel code. So the supporting PQR, you've got the weld procedure number and then the supporting PQR. And then our next line, we've got welding processes, shielded metal arc welding. So you might have 2 or 3 processes listed there. That could very conceivably happen. You could also have a situation where you got 3 or 4 different processes. It's just bookkeeping at that point. Types, manual, automatic, semi-automatic, robotic. It's got them all listed right there. So you could have shielded metal arc welding, you can have multiple processes listed there, where it's like type, and then instead of manual, you might have manual and then automatic or semi-automatic. Joint design. All right, QW 402 and ASME section 9, addresses the joints. So you don't have to, on your WPS, you just need to address the joint designs. And you can leave it kind of open-ended, like this one. You don't have to lock it in so that it's a very tight joint configuration. You can leave it so, like this one, the way this one was written is you could have a single V, a double V, a J, a U, and you can also do fillets. And I don't know why when they wrote this, they threw in the weld joint. I generally don't put in a weld joint, but this is, I guess they were saying if you're going to use this, if you're going to do a V groove, this is how we want it done. I generally clean mine up and then just put in there, follow the directions on the joint design on the, on the production drawings or on the blueprints, right? So then it's all wide open. And then if there's certain instructions you need to give them, maybe you'll have a supplementary document that kind of touches on that one. Another thing to take a look at on joint design is, what kind of backing you're using, if you're going to use backing. Also, the backing material type, and then retainers. Retainers and backing aren't the same thing, if that makes any sense. So a lot of times I always throw in, when I would write a WPS, I would throw in something about retainers not being used, because then you're addressing that variable on your WPS. Also, I'm not, before we get too far into this, I generally never used software to write a WPS. I generally used, just would hammer them out on, I had a Word document and I just do them that way. I worked at companies that had that situation. They didn't really have the software, so I never really learned how to use the software. And then I got into a job where I was reviewing a lot of documentation, so it's just somebody gives you a stack of WPSs and then you dig through them and read them and decide, hey, do they address all the essential and non-essential or supplementary essential variables? So you're going through these, stacks of these. So that's kind of where I cut my teeth doing this. And I guess I'm trying to give you a little insight into what I used to look at when I was reviewing a lot of these. But anyways, non-fusing retainers, or you got to address retainers. And here you can see they just checked metal. So for backing, they're not going to use ceramic backing or copper or whatever. They're just going to use weld metal or P1 as their backing. Okay, so when we get to looking at base metals, you're talking about, groupings of materials. And you can go a lot of different ways with this. If you're using just an off-the-shelf material, like that's got a P number, ASME breaks their materials down into P numbers. It's groupings. So all your carbon steels that are more or less the same, they're P1. All your austenitic stainless steels that are more or less the same are P8. And it goes to weldability, tensile strengths, a number of different factors go into deciding what material goes into what P number. And sometimes they, as new materials come out, it'll become a new P number. I think about 25 years ago, I could be wrong, but I think a bunch of materials went from being 5C, P5C, and I think they became P15E. That's a bunch of these high temp creep resistant materials, if my memory serves me. But anyways, there got to be enough of them, and the people in ASME decided this stuff's a little different than what we previously thought. It gets its own P numbers. So that's what the P numbers are. So if you qualify a weld procedure with a P number 1 material, you can weld all the P numbers with that. The group numbers come in when it starts needing to be impact tested. So, but these guys are saying, yep, you can weld any P number 1 to any P number 1. Some situations you might have I worked at places where we had a P1 to a P8. So we could weld any carbon steel to any austenitic steel with a P8 P number. So that's something you need to take a look at. And you see down here in that blue square or blue rectangle where I outlined it, you've got specification type and grade and chemical analysis and all that. That is for, let's say you're welding some kind of Lithuanian steel to a P1 or some material that doesn't have an ASME P number, it's not an ASME material. So you can weld it, you just have to qualify it. So you can just weld that stuff to whatever material you qualified it to. Or if you want to write your weld procedures very specifically, you can just put in whatever number you want in there. And I'll go to another slide and we'll take a look, see at that one, and I'll explain. So you can see here that they've got P1 Group 1 to P1 Group 1. But they also put in specification type and grade, A106 grade B carbon steel to A106 grade B carbon steel. Well, that's all they can weld. If you list one grade on there, that is all you can weld. That's the way I read it. And that's the way I cut my teeth. So you got to be careful when you're writing in base metals. You want to leave it kind of broad, or if you want to narrow it up and say, all right, this procedure is for this. But I've reviewed weld procedures and said, no, dude, you can't weld that with this. Well, yeah, I can. It's a P1 material. And I tell them, look at the way your weld procedure is written. Your weld procedure is written so that you can weld A106 to A106. If you want to rewrite your WPS, feel free to do so. I'll accept it, but you need to widen that up and get rid of that where it says A106 to A106. I don't know why you'd include that on here, but sometimes guys do when they're writing them, and sometimes it's a mistake. They think they have to be specific, but no, you just need to put the P number on there. And if it's impact tested, then you got to put group numbers on there. But basically, you kind of want to leave it as wide open as possible. And so, like I said, sometimes chemical analysis or whatever, there's provisions in there. If you got to weld some really weird stuff to something else really weird, then that's where you put in, the chemical analysis, the specification type, or, you get really down in the weeds and, a very specific material that doesn't have a P number. And in here too, it's your thickness numbers. This thickness number information is going to be dictated by your PQR. How thick a material did you qualify on? Okay, you're going to look on a little chart in ASME section 9, and it's going to tell you, how thick of material your welder can weld on. So they've got a little chart there in the back that'll get you dialed in. You can see on this one, as we're working down this, here we're at filler metals. Just remember, just because there's a blank on a document doesn't mean you have to fill it in. So some of this information, electrode flux class, flux trade name, consumable inserts, I generally just put NA or none if it doesn't apply to what I'm doing. So electrode flux class or electrode flux name, that's for shielded or submerged arc welding. We're talking about shielded metal arc welding, right? We're talking about E6010 and E7018. So we're talking about shielded metal arc welding. Some of these spaces are for other processes that have nothing to do with what we're doing. So something to keep in mind. So you list your, your weld materials, your specification number, the ASME, AWS, SFA number, 5.5 and 5.1. And then, you list your AWS classification, what materials you want your welders to be using. And then your F numbers and A numbers. These are essential variables that you need to address. The A number is going to tell you, you're going to get that off of, what filler material you used. Because within the way they've got the filler metals broken out, I could have E7018, which is a F3 material because it's a fast fill or a fill freeze material, and it's 70 tensile strength, 70,000 tensile strength. But let's say I start using let's say I have 11018. It would be the same F number, an F4, but my A number is going to be different because E11018 would have 110 KSI tensile strength, but its chemistry is going to be way different. The flux coating is going to be more or less the same, and it's going to weld the same, but I've got a whole different chemistry for it. So my A number is going to be different. So something to keep in mind, F numbers and A numbers. I should probably do a short video on A numbers, but I don't seem to be able to do short ones. So your size of your filler metals, that's not an essential variable. It's just telling the welder what he can use. So if it says they can only use 1/8 inch rod, that's the only thing they can use. Or if you want to widen it up and they can use 1/8, 332, 532, 3/16, well, you can do that. But you need to, even if they make 7018 in 1/4 inch diameters. I used to weld with that stuff back in the day. Stuff is run with 350 or 400 amps. Anyways, let's say I wanted to use E7018 1/4 inch with this weld procedure. I can't do it. Even though it's qualified, material-wise, chemistry-wise, it's not listed here, so I can't use it. In order to use it, I would have to have my welding engineer go write another weld procedure or revise this one and add the new size of filler material to it. So a lot of this WPS stuff is bookkeeping. And then we've got our thickness ranges, how much filler metal we can deposit. All this is determined by ASME Section 9. I'm not going to get into off in the weeds talking about that. And, you got consumable inserts and other, things that don't pertain to us in this weld procedure. They're just blank lines for other welding processes. This is usually on the second page. And once again, you don't have to follow this format. This is just a suggested format. And a lot of what you'll see out there in industry looks like this. But sometimes you'll get some in and it won't follow this format. So you just kind of got to dig through what they've got and go from there. Positions. You've got to address the positions. So this is saying you can weld in any positions for fillets and or groove welds. The key here is the welding progression. This is where you can get in trouble. If you want your guys to run downward, go ahead. But most people will make sure that the welders are welding uphill. It's just a general, I don't know how to say it, but just generally it's better to go that way. There's a lot more problems you can run into running downhand. If you look in the little blue square there, I've got the WPS number, but also post-weld heat treatment. I generally throw in none. I think they changed the rules on NA versus none with ASME Section 9, but I'm a big none guy. If we're not doing it, I just put in a none. I don't put in the NA. I just put in none. The yellow one, we're doing shielded metal arc welding. We don't have gas. So this is a situation where it's NA, or you could put none. Once again, it doesn't pertain to this welding process. Just ignore it. Like I said, a lot of people, I think, get freaked out and think they have to address everything, every empty box that's on here and put something in there. No. Purple box is preheat. This is something that's got to be addressed. You need to let the welders know, hey, this is how warm the material needs to be before we start welding. And the interpass temperature. What's the maximum interpass temperature? Interpass temperature means if the weld metal's above this temperature, I can't weld on it anymore. So it keeps bad things from happening metallurgically to your base metal and your weld metal. Keep it from getting, bad things happening, without getting off into the weeds and talking about the whole metallurgical, the whole science behind what happens if you overheat a piece of metal. Preheat maintenance. Preheat maintenance is basically is this a piece of metal that let's say we stop and go to break and go to lunch. Do I need to keep this material at a certain temperature until I come back? So no preheat maintenance required. This is a carbon steel. We're like, no, you can heat it up, cool it down. We're not going to damage it. But there are certain materials out there that when you quit welding on it, you better have some heat on it, or you're going to have cracking, or all kinds of bad things are going to happen to you. So that's what we're talking about when we talk about preheat maintenance. Preheat maintenance means, do we need to keep it heated while we're not welding on it? The welders went to lunch. We're going to keep it at 400 degrees while they're gone. They're going to get back and start welding. Or with no preheat, they went to lunch. It cools down to room temperature. We start welding on it when they get back. Life is good. Electrical characteristics. AC or DC, what are you running? Polarity, are you running reverse or straight? And then for volts and amps, there's a chart below that I generally use, or you can put it here. There's no hard and fast rule as to where you need to address these things in a weld procedure. You just need to address them. Tungsten size and type, we're doing shielded metal arc welding. We don't need to address that. Mode of transfer for GMAW. We're not doing gas metal arc welding. Although for gas metal arc welding, you need to address this. This is an important one. You will get in trouble. You need to, if you're writing a weld procedure and you're talking about gas metal arc welding, you need to realize you can't go into, you can't say it's spray arc and you've got carbon dioxide as your shielding gas and you're running at 20 volts. You'll need to understand the whole spray arc, metal at transfer, the 4 metals transfer modes for gas metal arc welding. This one you can get in trouble in. Electrode wire feed speed range. Once again, we're not doing flux core or gas metal arc welding or submerged arc welding. Not applicable. We're not going to touch it. Okay, for technique is, I don't think any of these, I'm pretty sure none of these are essential variables. I'd have to go and look. But they're all need to be addressed. So for technique for different welding processes, so this one's saying, can I run a string or a weave bead? You can do either. Orifice or gas cup size, it's not a variable that needs to be addressed for shielded metal arc welding, but for other welding processes it is. It's telling you're giving instruction to the welder on how big the orifice or gas cup size can be on their TIG torch or other torches. Interpass cleaning, brushing, grinding, etc. Okay, this is usually a biggie. Initial and interpass cleaning. This one comes into play when you're welding austenitic stainless steels and nickel alloys and titaniums and things that are a little more finicky or delicate, I guess, than your garden variety carbon steels. So a lot of times for initial interpass and cleaning for a titanium or a nickel alloy or aluminums, you're going to have a pretty good little document that explains exactly how you want that material cleaned. Don't use carbon steel brushes on it, all kinds of things. Method of back gouging. If you need to do back gouging, okay, you're saying this is carbon steel. We're not going to mess it up. So we can use any mechanical. We can use grinders or whatever to chew it out. Or we can use a torch or, plasma or air arc or whatever we need to do to chew that material out of there. Other materials, if you're on a titanium or something else, you're going to be a little more picky with your methods. oscillation, contact tube, multiple or single side. Yeah, is it a multiple or single side? Well, it depends on what kind of joint we're working with. Multiple or single electrode, single. I think this one more comes into play with things like submerged arc welding, where you can have 2 or 3 electrodes pumping metal into a weld joint. Travel speed range, you kind of give them a range you want to run at. And then peening. Peening is one I used to, have people fix all the time because they wouldn't address it. I've never run across peening. I've seen it, in videos or whatever, but, peening, none. Don't do this. Or you can peen the second through the, last pass or the second to last pass, right? So this is what their technique, QW 410 in ASME Section 9. But as you go through your list, of essential and non-essential variables, it's going to tell you what you need to address in there. And then you just go through and address it. And if you're reviewing a document, you go through there and, they didn't address this. So you write yourself a little text document or a little Word document, and you just put on there, nope, you didn't address this. You need to address this. You need to address this. It's kind of how I did it. So here's where you've got, the list of weld layers, the processes you're going to use, the filler metals, the currents. This is where you're going to list the nitty-gritty of what's going on with your welding procedure, how they should run, pretty much everything in regards to, diameter, sizes of filler metals. You build yourself a little grid here and tell the welder exactly what you want done. And like I said, I think with the software, a lot of times it'll just do this, but I'm old school and I never worked anywhere where they actually had the software. So I just kind of did it, got used to writing them. I had a Word document I'd work off of, had a couple of lists, would write them, send them off, deal with people, argue a little bit and get it back, make my adjustments. Or I was the guy reviewing it. I'd review it and, send them what I want fixed, address this, this, and this. Here's an example of what an ASME, American Society of Mechanical Engineers, welding procedure specification would look like. Once again, you don't have to use their suggested format. This is just a starting place. I've worked at different organizations that had stuff that was, their documentation was completely different for welding procedure specifications. So just as long as you address all the variables and get all the information that's required on there, you can use whatever format you want, as long as you can track it and your customer can figure out what's going on and it's in some sort of legible format. As long as you address everything, you can use it. But this is the general format that is used by the American Society of Mechanical Engineers. This is an ASME Section 9 suggested format for procedure qualification record. You go through here and for ASME Section 9, you address all the essential variables. And if you want to address non-essential variables, you can. You do not need to fill in every blank on here. If you fill in every blank, you're going to get yourself into trouble. If you don't do something, do not put NA, like post-weld heat treatment. Use the word none. If you did not use post-weld heat treatment, put none. Don't put NA. It is applicable, and you just didn't do it. None. None is better than NA. A lot of times when you're sending these in for review, somebody is going to look at it and say, he put NA, he should have put none. You need to put none. So don't fill in all the blanks. Make sure and address all the essential variables, and you shouldn't have too many problems. Once again, you don't have to use this format. It is recommended, suggested. You can use something else if you would like. This one works for a lot of people. Maybe it doesn't work for you. You don't like it. You don't like the colors. You don't like the lines, whatever. You can invent your own format and go with that. As long as you address all the essential variables, you are good to go. On this slide, you can see the GMAW weld procedure essential supplementary, essential, and non-essential variables. In all codes, they have different formats for telling you what your essential, supplementary, and non-essential variables are. But when you're qualifying a weld procedure, you need to look at the code you're qualifying it to and what the code requirements are. What are the variables you need to keep track of on the PQR, the WPS, and how you need to explain those and document them. The different codes have different requirements. GTAW weld procedure variables. We've got a couple of slides, like I've said, that we're going to show that, it's just the welding variables for specific processes that you need to document on WPSs and PQRs when you're doing a procedure qualification. So you've got essentials, supplementary essential, and non-essential variables. And these are going to vary from process to process. The essential variables for submerged arc welding are not the same essential variables for shielded metal arc welding or gas tungsten arc welding. And they're not all going to be the same from code to code. So you just need to be cognizant that somewhere in each code there is a weld procedure variable table that's going to tell you what you need to address to put together a proper procedure qualification record and welding procedure specification. So essential, supplementary essential, and non-essential variables. And not all codes use the same terminology, but it's pretty much the same. Essential, non-essential, and sometimes you got supplementary essential. All right, that was kind of a quick overview through how to read a WPS. I don't know if it's useful or not. I guess I'll figure that out by how many people watch this. If you have any questions, comments, there's my email address. Shoot me an email or just answer a question or ask a question in the comments on the YouTube video. But if you have any questions or you think this was worthwhile or an absolute waste of time, let me know. Or, if there's some things that I could do to make it better or maybe do a second part, let me know. I just kind of tried to go through it real quick and, not have it turn into a 3-hour slog. So anyways, everybody take care. My name's Gary Pace, PE, CWI, Katy, Texas. TexasWeldingEngineering.com is my website. And got any questions, comments, track me down. GP out.